Today we're going to start with the mechanical mates. So last session we have seen standard mates and advanced mate. So this session we're going to see mechanical mates. Okay, so we'll go to the mechanical mate folder. So let's start with first part, cam mate. Okay. So here I have one part. I'll bringing it first. This part I want to fix on my assembly planes. So let me change the background here. So we're going to float it, right click and float. So this is now movable. I want to fix this on assembly planes. So we're going to mate it first. Mate this plane and the top plane, front plane and the front plane, right plane and the right plane. Next, we'll hide these planes. Now bringing the cam and follower arrangements. So insert component, bringing cam mate and follower. Okay, so we'll assemble them. Go to mate option, selecting the circular face to circular face. So applying concentric relationship. This face to this face concentric. So now this part can be rotate here 360 degree. So I want to arrange a cam and follower in such a way that cam rotate and follower do up and down motion here. So we'll take advanced mate. I want that follower to be arranged at the middle of the cam. We'll use width mate. We'll select one face here, one face here. Then we'll select one face on this part and one face on this part. Do OK. Now we're going to assemble this. So for that, we're going to mechanical mate and we have a cam option. We have to select a cam path and the follower path. So do OK and check. Like when you move it, you see it's moving with the cam. So I want it do not move with the cam. It will only do one motion up and down. So we have to restrict the degree of freedom for this part. So let's see what we can do here. So here I'm going to put one more relation, a standard mate. Right plane of this part and right plane of the follower. So I'm taking right plane of the follower to be aligned with each other. So they are aligned now. So it cannot deviate from this like directions horizontally, but it can move vertically. Now you can see here. So this we can do now. If you want to make a animation of this, you can take the mate type. Oh, sorry, you can go to new motion study. There is a motor is there. You take a motor and click on this. Define the RPM and what type of motion you want to do. Rotary motion. Do OK here. And then you can increase the timing, how much time you want to see that movement and calculate the animation. So this is how you can create an animation also. Next, we are going to see gear mate. Let's take a gear assembly. How to make a gear assembly. Let's do OK. So taking a base plate for this part, same way. So I'll fixing this gear plate on the assembly planes. Let's make it float and show the planes and assemble each other. Mate, front to front, top to top, and right to right. Now we'll hide this planes. We'll bring another component. So gear part, I want to bring it here. I'm going to assemble this gear with this part. So we'll go to mate option, select this and select this. Do OK. So that will concentric. Now this face and this face should be coincide. Do OK. Now I want to repeat this part this side. So what we'll do, we'll go to the option, copy with mates, select this part. Next, Now you have to repeat for this face and that face. So you select that faces, it'll be do repetition and it will be assemble there and do OK. Now they are placed, they are not in relation to each other. If you move, you can see it will be passed through that. So I want that will be maintain a gear relation. If I move one gear, that will be rotate second gear. So go to mate option, mechanical mate, and we'll take a gear mate option. We'll select this gear and this gear and do OK. Now you can see if you rotate one gear, the second gear will be rotated. You can animate them if you want to make animation. Again, you can go to new motion study. You pick a motor from here, select the motor and place a motor. Take to rotary motion and do OK here. Define the time. So let's take 5 seconds and calculate it. So this is how you can make a animation of the gear also. Next, we'll see how to create a hinge relationship. So let's take new assembly. So I'll just bring a hinge here. So I want two hinges. Okay. So what I'll do, I'll just copy this by pressing Control and drag that. Now we'll adjust this by rotating and adjust that on the screen. We'll go to rotate and I'll adjust this like this. I want to place this. So this one is fixed because we haven't moved. So we haven't made float. So it is fixed, but this is free to move. So directly go to the mate option, mechanical mate and hinge option. In hinge, we can define two concentric faces and two coincide faces. I say this face and this face should be concentric and this face will be coinciding with this face. So this will be assembled. So this is fixed. So this can move. Okay, you can see it have a movement. Now you have one more thing when you're applying this mate, hinge mate, you can apply angle also if you want to limit the angle. You can tell how much angle it can move. Like I said, it can go up to 180 degree and then it will be stop at 15 degree before that. Do OK. Select the two faces between you are applying. Do OK. Now you can see here. So it will be stop some degrees and then it can move up to 180. Okay. So you can change the angle. 180 is too much. Let's take it 150 better. So now it will be stopped at 150. Before that, then it'll go back. See, till 150 it will go. After that, it will not go inside the body. Like this, you can apply and make a hinge mate option. Next, we can make a slot mate. So for the slot mate, let's take a slot here. We need one slot. I need one object. With that, we want to make a relation in this. So insert component, second part. I want to assemble this part here in the center of the body. First, let me apply some mate. I said this mate with this face and this face that will be aligned. So that will be only aligning that with the face only. Okay, you can now make a relation with this and the slot. Go to the option, mechanical mate, and take the option slot method. Select this face here and that face, that cylindrical body. It will be center now, exactly to that face. So right now it is free to move. You can easily move between this slot. Okay, you can easily move to slot. Now next, you can also provide some restriction if you want. Maybe you want to fix at center, you can fix at center, it'll be fixed at center, it'll not move. Or you can tell by distance also. You can say I want to move by some distance or percentage. Okay, 20%. So it'll be 20% will be leave away from that, it'll be fixed there. Or you can give the distance also. You can define distance value, where you want to fix it exactly. You can type the value here, it will be fixed at that position. So this is how you can use a slot mate. Next, how to use universal joint. Let's understand that. So we'll take a new assembly. Okay. So universal joint I want to make. So I have one part here and one more part I'm bringing here. In between that, I want to make universal joint relationship. So we're going to assemble this. I said mate. This circular face and this circular face will be like aligned. Then this face and this face will be coincide. So one part is assembled, and I want the same part to be like assembled here. So again, we can go with copy with mate option. We'll select the gear and next. Same process we have to do this side. So blue color face we have to show here, and then second again the blue color face is what this face will select it and do okay. Now both has assembled, but right now they don't have any relation. If you move one, there's no connectivity between that gears. With the universal joint, we can make that connectivity between them. We'll go to mate option and take the option universal joint, select this gear and this gear and do okay. You'll find that if you move one gear, the second gear will be also rotate. Okay. So like at what power you move, the same power will be moved. What the purpose of universal joint? To transmit of the same power to one object to another object. Next, we'll see how to apply a screw mate relationship. Let's take a new part. So screw mate will bring some part, one bolt and one nut shape. Bringing another part, screw. So you define that how you want to assemble it. So we directly go to screw mate option, mate, mechanical mate, and we'll take the option screw mate here. Define the circular face and the circular face that will be assembled. Now here you have option revolution per mm or distance per revolution. So you can define anything how you want to be defined. So let's take revolution per mm. I said 0.25 I want to define and do okay. So per revolution, how much it will move downward? 0.25. So according to that, which direction you want to move, you can see here, it will moving in that particular direction. Okay. So this is how you can make a screw mate relation to view the screw relationship between that nut and bolt. Next. Now last mate we have here for mechanical mate, that is the rack and pinion gear. So let's see. New assembly, okay. So we'll bring rack and pinion. I have one part here, rack and pinion. Complete assembly setup. So, okay, let me open a base body here. On that, I want to make my rack and pinion to be assembled. So bringing one other components. So I want to make one handle here, the shaft and this part. I'll place it one by one. Okay, so this is all I have to assemble in this. So I'll go to mate and I said this circular face and the circular face will be assembled. Then where it will be stop, I'll tell this face and this face will be stop on this. So can rotate here 360 degree. Then I'll tell this portion will be fit on that part. So I'll telling that face to be parallel to this particular face. Then we'll say that should be this circular face and the circular face should be coinciding with each other. Okay, parallel condition like we did it, but it's just at other side. So we'll flip it once. Now it's perfect. Now we'll say this face will be stopping at this face. That handle arranged. Next, I think that flipped other wrong side. So face is actually smaller now. So let me delete the relations and then arrange it first properly. So parallel is what? Between this face. Mate. This to be parallel. This face. And this face. Then you can tell that it should be concentric with this vertical face. And you can stop this face over this face. It fit now properly. Okay. Other side, actually, what happened? This hole is smaller now, so I just taken wrong side. But that is for this part. So we'll tell that now this face to be parallel with this one. You can flip it also side. This face will be assembled to the circular face. Then tell that where to stop actually. So we'll tell that this face will be stopping this face. So it is easy for me to pick that handle. I can rotate right. Now we'll bring our rack and pinion to be assembled here. So insert, bringing a rack. So first I'll assemble this mate. Go to advanced mate, width mate. I say this face, and this face and this face will be becoming to center of the body. Then I'm telling that should be coincide. So standard mate. So say this face and this face will be coinciding with each other. So it'll be fit here. Okay. Now I want a rack and pinion. So we'll just take that. So I'm taking here a pinion. So that will be a gear. So this pinion will assemble over this part. So mate. So we'll tell this face is parallel to that cutout. Then this cylindrical will be assembled. Again, the gear have to fit at middle. So I'll go to advanced mate, width mate, this face and this face, this face and this face. Okay, like this we have taken. Now you can arrange it. Okay, now this portion actually required some calculation. So that calculation you have to calculate it actually. Without calculation, we cannot make a proper mechanism. We can apply relation from the software. We take here mate option, mechanical mate, and we have a rack and pinion option. So we'll define one rack edge and one pinion edge. Now here, you should know this actually. Okay, you should know this detail. If you know this detail, then only you can perfectly make pinion pitch diameter or rack travel per mm. You can define it. Okay, it's taken 301. Let's take a default first. Okay. So when you move this, you can see it will be moved. Like you can change directions also. You want it will be reversed in the direction. You can reverse it. So means if I move in that direction, it will be reverse, move in reverse direction. Like this, okay? Yeah, this way you can do it. So this way how you can make a rack and pinion mechanism. Okay, so that's about mechanical mate assembly.